Hi, today I will show you how to implement a lighting system like this one in Godot. First, let me explain how the lighting system will work. We will not be using any light, like proper Godot light, in this lighting system. Instead, all we're doing is placing markers on the screen to set where the light sources are going to be. And then, on a separate layer, we paint areas that are in shadow with this dark blue color. And finally, we blend the two using a multiply layer mode, and we lower the opacity to taste. And that gives the impression that the areas that are lit by a light source are actually lit, but what we're doing is the opposite. We're darkening everything else on the screen that is supposed to be in shadow. Here I am in Godot, and my starting point is going to be the same as for the last tutorial about mirror reflection. So if you haven't seen that tutorial, maybe you want to have a look now, at least at the beginning, so you understand how this is set up. But basically I just have a character here that I can move into the space with the arrow keys, and some walls with collisions. The only thing I'm going to change for now is add a camera 2D to my character, so that when I move around the scene, the character remains in the center. And this is going to help us later on make sure that the lighting system is set up correctly with camera as well. If we want to lit a scene, we need some light sources. As I showed you in ASprite, the light sources are going to be just positions on the screen. So for that, I'm simply going to use a marker 2D. So let's add one now to the character. We'll place it somewhere around here maybe. And the only thing that we need to do to know that this is going to be one of the light sources in our scene is to go to the node and the groups property and set its group to light. And this way we have now a light source for the character. I have also created some lamps that we can use. We can have a look at it quickly. It's a very simple scene with a rigid body 2D, a sprite, a collision shape, and the same marker 2D for the light source. So we have one here, and I will just copy paste it and place it somewhere around here. And with this we're set up and we can start working on the lighting system itself. For the lighting system, as I've shown you in ASprite, we have a layer on top of everything else on the screen, and we darken areas of the screen using that layer. So we'll do something very similar in ASprite. I will first create a canvas layer, and within that canvas layer I will create a color rect. This color rect is going to cover the entire screen, so it needs to be the same size as the resolution of my game, which is 320 by 180. And right now everything is white because this giant white rectangle is sitting on top of everything else. But we will now set a shader material to it, and we'll create the lighting shader itself. So I'm going to say new shader, call that lighting, and edit it. So you see that Godot has set up a very basic shader for us. We have a vertex function and we have a fragment function. We don't need anything else but the fragment function, so I'm going to delete everything around it. A fragment shader is a function that is being called for every fragment or pixel. In our case, it's going to be every pixel on the screen, simply because the color rect covers the entire screen. Let me replace this with this very simple shader. As you can see, it looks like we don't have a color rect anymore covering the screen. And the reason for that is I'm sampling the screen texture for every fragment or pixel at the current coordinates of that fragment and putting that as the color of the fragment. You can see the screen UV here. This is using the UV coordinate system, and it's like XY, it's just UV, and it goes from 0 to 1, the origin being the bottom left. We now need to send the light source positions to our shader. And for that we can use uniforms. Uniforms are variables that are used to send data from the CPU to the GPU, and we've already used one actually with the screen texture here. I'm creating two new uniforms, one that is an array of vector 2 for the light positions, and a second one that is going to keep track of the number of lights in the scene. Now that we have uniforms, we need to send data to our shader. Let me rename that to lighting and create a new script for it. New script, lighting. Okay, so here what we're doing is iterating over every light by looking for all nodes in the tree that are in the group light, And for each one of them, we're getting their position based on the canvas transform, which means the position based on the camera. And within the process function, I'm getting the light positions and I'm setting the two uniforms in my shader. The number of lights is going to be the size of that array, and lights is going to be the positions themselves. Now let's go back to our shader and see how we can darken the screen. I'm adding a new uniform. This time it's going to be a vector 4 for a color, for the 4 channels of a color, and I'm going to name it Modulate Color. And what I'm doing is multiplying the color of the fragment or pixel by that new Modulate Color. And what this is doing is the same as using multiply in a software like GIMP or Photoshop. If we set the color now here to a dark blue, let's say, maybe not as much, a bit less tinted, it actually darkens the screen. So we now need to calculate the distance of the current pixel or fragment to the closest light source. So let's add a new function called distance to light. This function is going to take coordinates and iterate over each light source, and for each light source calculate the distance from those coordinates to the light using the built-in distance function, and then keep the smallest value, so the closest light source we find, and finally return that distance. We can now use this new distance to light function to get the distance of the current pixel from the closest light. Let's put that in a new variable called dist, and call distance to light from the current coordinates in x, y. And what we can do is say, if this is more than a certain amount, so a certain light radius, then we will darken the current pixel using the Modulate Color. If we run that now, you can see that I'm actually darkening only areas that are further away than 64 pixel radius of every light source in the screen. 64 pixels might be a bit large, and you might want to extract that into a uniform, so you can set it to whatever you want. So let's name that light radius and make a new uniform here. This uniform is going to be a float, and I'm setting its default value to 32. So if we run it again now, see that the lights are a bit smaller, which looks better in my opinion, and we can change it to whatever we want here from the inspector. We don't even need to run it again, it's going to change live. There are lots of variations that you can do on a lighting system like this. One that I like to do is to introduce light bands to make the transition between light and shadow a bit more smooth than the one that we have currently. And I have made a band radius here of 54 pixels with a band strength of 0.3. And I've extracted the code to modulate the current fragment or pixel into this modulate function. And what I'm doing is, if the distance to light is more than the band radius, then what I'm doing is modulating, but only based on the strength of the band using this mix function, which will just interpolate between two values using the third one as the interpolation. If we run it now, you can see that I have my light band, and I think that looks a lot better. That's it for today. Thanks for watching. If you enjoyed the tutorial, please consider subscribing. See you next time. Take care.